Okay, today we are in Unit 5, Day 6. We're still working on similarity, but we're actually looking into what happens with the similarity ratios when we look at the perimeter in the area. My printer is not of great quality this morning, so we're going to try actually doing this directly on the screen, and we will see how it goes. So if you'll flip to your packet, I'm looking at Day 6. Pretty straightforward to look at. We've been given two rectangles. We're told that they're similar. We're looking for their perimeters and their areas to begin with. I'm going to start by looking at this first rectangle here. I've got one of my lengths is 3. That means its opposite side is also going to be 3. So I'm going to go ahead and label that. I've got this length of 9. I know that its opposite side is going to be the same, so I'm going to go ahead and label that to be 9. If you remember, if we're looking for the perimeter, we're adding up all the lengths. So I have 9 plus 9, 3 plus 3. That ends up giving me a perimeter of 24. While we're at it, we're going to look for the area. If you remember, the area is just length times width, or base times height. So 3 times 9 would give me a 27. I'm going to go do the same thing for my rectangle over here. Again, I'm labeling the opposite sides because I know the opposite sides in that rectangle are going to be the same. The perimeter, I've got 2 6s and 2 2s. That ends up giving me a perimeter of 16. And if we're looking for the area, 2 times 6 would be 12. First thing they want us to find is the ratio of their sides. Just make sure you're picking any of the corresponding sides. I'm going to look at the smaller sides. I see a 3 and a 2, so we can write that as 3 over 2. If we go look at the ratio of their perimeters, and I'm going to start off to the right, I see 24 over 16. And we're just going to reduce that down. 2 goes into both of those. I get 12 over 8. 4 goes into both of those, and I end up with 3 over 2. So let's go back here. That means the ratio of their perimeters is 3 over 2. Next, they want us to look at the ratio of their areas. So let's go back and look at their areas. I've got 27 over 12. Again, I'm going to come write it down over here. 3 goes into both of those, and I end up with 9 over 4. Again, as always in geometry, we're looking for some type of pattern. So kind of look at what the ratio of their sides were, the ratio of their perimeters, and then finally the ratio of their areas. Clearly the area ratio is not the same, but maybe there's a pattern. We're going to go do the same thing for the next set. Example number 2, we're looking at their perimeters and their areas. Notice this triangle is isosceles. That means I've got 2 of the sides are the same. So I'm going to go over here and label this to be 10. I'm looking for the perimeter. Again, I'm adding 10 plus 10 plus 16. We end up with a perimeter of 36. If you recall, the formula for area of a triangle is 1/2 base times height. I'm going to put a little bit of work over here for you. That means I would have 1/2 times 16 times 6. So half of 16 is 8. 8 times 6 gives me an area of 48. Let's go to the second isosceles triangle. Again, I've got this side to be 5. Adding up all of those sides, we get a perimeter of 18. My area is 1/2 times 8 times 3. That would be 4 times 3, which is 12. Going back to my ratios, we're looking for the ratio of their sides. I see 10 over 5, which reduces to 2 over 1, and I'm just going to write it for sake of space and difference as 2 to 1. We're looking at the ratio of the perimeters. I've got 36 over 18. That reduces to 2 to 1. Finally, we're looking for the ratio of their areas. That is 48 over 12, which reduces to 4 to 1. I'm going to give you a minute to just get caught up, make sure you're on the same page. So again, we're looking for a pattern. Ratio of their sides was up here, that was 2 to 1. Ratio of their perimeters was 2 to 1. And then finally the ratio of their areas was 4 to 1. All right, continuing on. We're going to take a look at circles. And really when we talk about a side of a circle, we don't have a side. We've got just one dimension, and that's their radius. So first thing I'm looking for is their circumference. I've got 2 pi times 5, and I'm just going to leave that in terms of pi. That would be 10 over pi. The area, if you remember, is pi times my radius squared. When I simplify that, we end up with 25 pi. I'm going to go do the same thing for that smaller one. Again, circumference would be 2 pi times 2. That would be 4 pi. My area would be pi times 2 squared. That ends up giving me 4 pi as well. I'm going to go look at the ratio of their sides, which means the ratio of their radius. We get 5 to 2 here. If I look at the ratio of their perimeters, I've got, which is their circumference, which would be 10 pi over 4 pi. Those pi's can cancel out. 10 over 4 reduces to 5 over 2. If we go look at the ratio of their areas, that is 25 pi over 4 pi. Again, if you notice, the pi's cancel out, and we are left with 25 over 4. Again, we're looking for a pattern. I see a ratio of 5 to 2, 5 to 2, and the ratio of their area is 25 to 4. Let's go take a look at a few examples then. So in the first case, we're given a similarity ratio, which would be the ratio of their sides is 2 to 3. You may have noticed the perimeter ratio stays the same. It is still 2 to 3. However, when we get to the area ratio, it's not the same, but there's a pattern. The pattern is we are squaring both the 2 and the 3. That means we end up with an area ratio of 4 to 9. Let's save that second one for just a minute. The perimeter ratio is 4 to 5. That means my similarity ratio is 4 to 5. My area ratio, again, is not the same, but to get to it, I square both of those. Now we're looking at the area ratio for that second example and how we get back to both of the others. Well, you might notice to get from column 2, to get from here to here, we're squaring it. So if you think we want to go backwards, that means we would want to square root it. Now, 18 and 50, I can't take the square root of. However, let's come over here and reduce it. 18 over 50 is divisible by 2. We get 9 over 25. So now when I go back, I want to take the square root of each one of those. The square root of 9 is 3. The square root of 25 is 5. Again, getting back to the similarity ratio, we get 3 to 5. Let's write a generalization, and then we're going to have to add just 1 or 2 more things on here. Sometimes you're going to see it written as a formula. In other words, if I write this in terms of the variables a to b, their perimeter ratio would still be a to b. Their area ratio would be a squared over b squared. Again, let me give you a minute to finish that up, and we're going to add one more thing. We're going to take this one step further. I think you've got enough room that you can add this on the bottom of your notes. Let's suppose we had the ratio of two sides of a rectangle is 2 to 3. We knew the larger area rectangle was 81. How do we go and find the smaller one? Now, you might be thinking we have to go back and think about what the rectangle area formulas are, but we actually don't. Think about what we just set up, and I'm just going to kind of set this up into columns here. This was the ratio of our sides. This is the ratio of our perimeters. When we get to the ratio of the area, remember we want to square it. And I've been given the ratio, the area of the larger is 81. That means I'm going to put that 81 on bottom because it corresponds with the larger side length, which came from here. And I'm looking now for that smaller area. Notice again, I didn't have to use any formulas other than thinking about these ratios of their similar sides. I'm going to cross multiply. I get 9x is equal to 324. When I solve that, I end up with x is equal to 36. Let's do one that's similar. Let's suppose we were given two hexagons, which you don't know the formula of, and the ratio of their sides was 3 to 4, and they give us the smaller perimeter is 15, and we have to find the larger. Again, I would kind of think about what column are we in, which one do we need to move to. Again, we're starting here with the ratio of their sides is 3 to 4. The ratio of their perimeters is 3 to 4. The ratio of their area is 9 to 16. Well, let's go take a look. We've been given the smaller perimeter. Perimeter is in this second column, so we actually get to stop right here and set up our proportion. We've been given the smaller perimeter is 15. That corresponds with that smaller number of 3. We've got 15 over x. Again, we're going to cross multiply. 3x is equal to 60. And finally, x is equal to 20. Let's do one last one. Let's suppose we were given areas were 48 and 100, and we had a small side of 10, and we have to find the larger side. Don't feel like you have to write down all the words, but let's go through. In this case, we're starting all the way over here in that third column. First thing I'm going to do is go ahead and reduce. 48 over 100. Each one of those are divisible by 4. And I didn't make this work out. That means I get a 12 over 25. Let's change this. Make our life a little bit easier. Let's change this to a 16. 16 divided by 4 is 4. Now remember, we talked, if we're here, how do we get back to these other columns? We take the square root. So the square root of the numerator, the square root of the denominator. They give me the length of the smaller side is 10. We're looking for the length of the larger side. So again, now we're just going to set up a ratio. When I cross multiply, we get 2x is 50, x is 25. Okay, we are running out of time. Do the best you can on the Excel assignment. If you've got some issues, send me some questions and I can post those in video format as well. Just do the best you can.